Hi dear students, we are going to continue with more trigonometric ratios, and I wanted to start again with the formulas for the sine, cosine and tangent. As you see, there is a method for memorizing easily, SOH-SAH-TOA method it is called, and we are writing only the first letters of the formula. Here sine means sine of theta is opposite of theta over hypotenuse, so sine is sine the first letter S opposite over hypotenuse. So it's coming like cosine is adjacent over hypotenuse, which is sa. Here it is. And tangent is opposite over adjacent, it should be, which is toa also. So we can easily memorize, I think, with these letters. Here we are going to solve the questions by using the trigonometric ratios. If sin x is equal to 1 over 2, it means that sin x is equal to 1 over 2, then this ratio should be equal to 1 over 2 also in this triangle, which means opposite over hypotenuse, and which is opposite of x is 11, and also the hypotenuse is equal to q, so sin x is equal to 11 over q. At the same time, it is given sin x is equal to 1 over 2, which means that we are going to combine these two results and we are going to get this one, 11 over q. It has to be equal to 1 over 2. So if I crossly multiply these two, q times 1, it has to be equal to 11 times 2, then q is equal to 22, it has to be. If we check the here, when we find that's 22, if we check here it's equal to 22, then sine of x, it should be equal to, in this triangle I'm talking, 11 over 22, and when we simplify both of them by 11, you're going to see that these are going to be 1 over 2. Here I couldn't color this one. Here 1 over 2, it has to be, when you simplify both divisible by 11, 1 over 2. So we got the answer by using this ratio. Okay, here in this question one side is not given, so I'm going to find the third side by using the Pythagorean theorem. By using the Pythagorean theorem means, here if I say this is equal to a, then a squared plus 12 squared, it should be equal to 13 squared. This is the Pythagorean theorem, you know. A squared plus 144, it has to be equal to 169. A squared is equal to 169 minus 144, it should be. A squared is equal to 25, then a should be equal to root of 25, which is root of 25 is equal to 5, it should be. Here it's going to be equal to 5. Then we are going to continue with the trigonometric ratios now. If you remember here, and sine is then tangent is, if you remember this toa, sa and so words, then tangent is tangent of x, it should be opposite over adjacent, which is equal to, opposite of x is equal to 12 and adjacent of x is equal to 5, so it should be tangent of x, it should be equal to 12 over 5. And cosine, cosine of x, it should be equal to adjacent over hypotenuse, which is equal to, adjacent side is 5 over hypotenuse is 13, and sine x is equal to opposite over hypotenuse, and it should be equal to opposite side is 12 divided by 13, it has to be. So as you see here, we found all the trigonometric ratios of angle x by using the formula and by using the Pythagorean theorem here. Okay, this is the last exercise it's going to be. The rest of them we will solve in the class. If tangent x is equal to 4 over 3, then find other trigonometric ratios of x. Again, we are going to find them by using the here trigonometric ratios. 4 over 3, it should be here, if I name this one like a. Tangent x is equal to tangent x in the triangle a over 6, and tangent x, it is given also 4 over 3, which means that we are going to say a over 6, it has to be equal to 4 over 3, which means crossly when we multiply these two, we are going to get this equation. 3 times a, it should be equal to 4 times 6, which means 3a is equal to 24. A is equal to 24 over 3, which means a is equal to 8, it has to be. So if a is equal to 8, by using the Pythagorean theorem, I can find the hypotenuse here, because for the other trigonometric ratios, sine and cosine, I need also hypotenuse. So if I continue with Pythagorean theorem, here a square plus 6 square, it should be equal to, let's say this is c, then it's going to be equal to c square. It seems like b, but it is 6, it has to be 6 here. So a square, we found it is equal to 8. 8 square is equal to 64 plus 36, it should be equal to c square. 64 plus 36 is equal to 100, is equal to c square. Root of 100, it should be equal to c, and 10 is equal to c, it has to be. Of course, we are using the positive results always here, because c is distance, that's why we are using only the positive results. This is the first one, this is the second one, and now third and fourth one, which means sine of x is equal to hypotenuse, opposite over hypotenuse, which is equal to sine of x, opposite is here 8, hypotenuse we found 10, I didn't write here, so it's equal to 8 over 10, but we can simplify by 2. I can simplify this 2 by 2, which means sine x is equal to 4 over 5, it should be. Okay, the next one, it should be cosine, because it says find all the trigonometric ratios. Cosine x is equal to adjacent over hypotenuse, which is cosine x is equal to, here it is 6 divided by 10, which means cosine of x is equal to, when we simplify by 2, it's going to be equal to 3 over 5. So we found all the trigonometric ratios. The next question we are going to solve in the class.